For those of you who understand carburation and mechanical distributors and mechanical advance and mechanical cars and mechanical everything, this video will be for you. For those who don't, you're gonna get a little bit of a history lesson. This is how the oldies used to tune their cars back in the 60s, 70s. So right now I have a little bit of a problem, as some might say. This is a L20B from a Datsun truck. From factory, these cars got a bunch of small equipment that's obviously not here. Stock exhaust, stock parts, everything. You know, they're meant to function with these things, and when you start to modify them, like this engine is very modified, you gotta make a little bit of adjustment here and there to really get the most out of the engine. It has headers. I don't know, name brand, jank brand, I don't know. It's got a fat ass cam on it, you've probably heard. Weber carburetor. It's rebuilt. It's got a 280ZX transmission. The way distributor timing works is it's basically just a rotor. Let me show you here. There's this thing here which spins. And if you could think of it simply, think of this part as charged with electricity from the ignition coil and from the battery. Basically electricity is coming out. This is a metal part here that spins around, and it basically just touches each of these pins here. These each go out to the spark plugs to fire the spark plug. The thing is, these engines, stock, they are tuned a bit soft from factory, and to really get any power and feel and gut out of these cars, especially after they're modified like this one, you gotta kind of mess with the timing a little bit, get them huffing and puffing a little more, you know what I mean? If you understand the basics of timing, ignition timing, combustion theory, all of that, pinging, detonation, advance, retard, and you'll kind of get the idea of how all of this works. You can think of ignition timing like this. As the piston comes up, the top dead center, you fire your spark plug to push it back down, and it's that same cycle over and over again. The thing is, as the engine speed picks up and you go from idle all the way up to 4, 5, 6,000 RPM, now that time is less. Now this is coming up a lot faster. Now you don't want to fire the spark plug here anymore, because by the time maximum combustion happens, your piston has already passed this and has started coming down. What you want to do, or what does happen, is the distributors, your modern cars, all these cars, they start to advance their ignition as the RPMs rise. So instead of, like, if this was idle, it would fire here and come down. It would fire here, come down. Now, this is a bit exaggerated, but at 5,000 RPM, when this is moving a lot faster, this is coming up and it'll fire maybe about here. So then as this is coming up, it'll fire here. And by the time it gets up here, that's when maximum combustion and the fuel and air gets ignited. Now that you have a general idea of how ignition timing works, now you have to understand what timing curves are, and that depends on when this touches each spark plug. If this is spinning, you want to create some kind of delay or some kind of advance to this, where it'll actually fire earlier and earlier. So it has to get from base timing at idle all the way up to about 4,000 or 5,000 RPM, and it's usually a gradual curve. Different engines are different. Sometimes engines like smooth curves, like rotary engines. Sometimes engines like a lot of advance and then kind of flattens off real quick. Really depends on the engine. And the way they do that is through vacuum advance and mechanical advance. As the RPMs pick up, this will actually move forward. So this will be tilted this way as the RPMs pick up. So if you can think of it, this is spinning like this. And then as the RPMs pick up, this whole plate, well, not this plate specifically, I'll show you down there, it'll tilt a little bit at a certain angle, and that'll cause this to fire earlier and earlier and earlier as the RPMs pick up. The goal for today is to advance the low end of the RPM range without advancing the high end of the RPM range. And why would you do that? Like I said before, these engines come with small equipment and all that, and at idle, they're meant to function with all that with a specific timing, so the emissions are right. So these don't actually run at maximum ignition, fuel ratio, timing efficiency. They run a little bit retarded. On this specific engine, the range is from 10 degrees at idle, and it goes all the way up to 36 degrees. Now, because this has a cam on it, you want more advance at the low range RPM to make up for all that extra air and extra overlap. So you don't want 10 degrees before top dead center of timing. You want something around 15, 18-ish. 20 is pushing it, but you want more advance at the low range. So what you can do, if you're a distributor guy, you'll know this. You twist this whole distributor. And what that'll do is that'll change the angle of this rotor, meaning, you know, you're advancing your whole curve more or less. If the car is stock, you just want it. So 10 and 36. The problem with changing the distributor and twisting the distributor is when you advance the low end, you will also advance the high end. So you move that whole range up. The problem is if you move the high range up too much, now this is the danger zone. Now you're advancing way too much and way too high at an RPM range. You want to keep this at 36 and only advance the low end. This requires a little bit more mechanical knowledge. If you understand how these work, you'll understand things a little bit better. Remember what I told you about how as the RPMs rise, this will be advanced more and more throughout a curve. You can actually adjust that curve once you get down into here. So we're gonna go ahead and take this apart. The 510s are nice. They have this little tray here for all your parts when you're taking apart your engine. Hey! Luckily for you guys, this will be quick. I've done this before. It's kind of obvious, but if you are going to do this, make sure you look into this deeply, because you mess up your distributor, you're going to mess up your car's timing basically, and if your car isn't timed correctly, it's not going to ignite correctly, and now you got a bunch of problems. So we really only need to worry about the mechanical advance. There is vacuum advance, this thing here, but you can Google that, figure that out yourself. I'm just talking about mechanical right now. This is the mechanical advance plate or thing. And these are the mechanical advance weights. And remember when I told you earlier, as the RPMs rise, there's more and more advance. So hopefully you guys are familiar with the idea of centripetal force. As things spin, the weight kind of moves out, flings out. So as the RPMs rise, this spins faster and faster. And what happens is these weights start to move out and out and out like that. This plate sits right inside, just like that. And what happens is, as the RPMs rise, this plate will move out further and further. You see that little tiny movement right there. I apologize, I've already done this mod, so I'm just coming back to do some fixing up, but you can still understand the idea a little bit. The rotor sits here, and it'll be spinning, and as the RPMs go faster and faster, the weights inside will move out, and you can see the rotor move a little bit like that. And that's your timing curve. So this is 10 degrees, or if this was stock, it'd be 10 degrees, 36 degrees. So you have about, what's 36 minus 10? 26? 26 degrees of advance right there. Like I mentioned before, this engine is modified, exhaust, cam, all that. And what I said before is we don't want 10 and 36 degrees of ignition timing. We want about 18, 20 degrees up to 36. That's what I'm aiming for. It's a bit advanced. The oldies and the Datsun forums will probably yell at me for going that advanced, but right. I don't know. So what do? You see these sliders in here? This is where those weights slide back and forth in. And what you can see, what I've done is I got a welder and I filled up this first section on these sliders. So now the range on the weights moving is limited. Now instead of 10 and 36, it's now 20-ish and 36, ideally. That is the basic idea of how you advance or change your advance curve. Not too bad. I thought this would be a lot more complicated. This does require a little bit of trial and error, so we'll get back to that. Another question you might have is how much material do you weld in? So you could do it trial and error, or if you understand numbers a little bit, if you know the stock timing of your mechanical advance, you could just do the math a little bit, because this should technically move linearly. What you do is you find the total travel back and forth, make sure you subtract the diameter of the pin here. Whatever that length is your range. For example, the slider moves back and forth 15 millimeters. That means 15 millimeters would be your timing range. And if you want to cut your timing range in half, you would weld up half of 15. So 7.5. I did some crude math here and I was a bit off. That's why this is a little bit too much. So I finished grinding down these a little bit further. You could tell I had to improvise a little bit. I didn't have the correct Dremel sizes to cut away material very efficiently. I had to use a couple other methods. Only thing left to do now is just to put it together and go for a little test drive. So after you put everything back together, make sure you recheck your base timing. In this case, you can't quite see, but I got my timing reset down to 20 degrees at idle. And then I've also confirmed that at around 4,000 RPM, it advances all the way up to 36 degrees. On your timing gun, you should be able to adjust it here. After that, go for some test drives and see if the engine's making any weird noises, knocking, pinging, detonation. In that case, you'll have to back off timing a little bit. Besides that, everything else should be good to go. All right. Welcome back to the POV. After you install everything back together, make sure you recheck your timing. Make sure it's set where you want it to be. I've been driving the car a couple days now, and immediately you can tell there's a very nice increase in torque, which is usually the side effect of advancing. Advancing usually gets you more power. You'll gain more fuel economy, more torque. Your car won't be as luggy. All that at the bottom of the RPM range is in there. Overall, the car feels a little bit more alive. It's a bad habit, but I kind of lug this engine a lot. This will honestly carry me around in like 5th gear at 30 miles an hour. When you do this mod, make sure you don't go out and start hammering on your car. You kind of build up to it, increase the RPMs, increase the load slowly. Listen very carefully for pinging and detonation. People say it sounds like marbles in a can, which is very true. Used to be high load would have a bunch of rattling up in the engine bay, and I was like, it doesn't sound like something's loose. It sounds like something's wrong. With these older cars, you can't really aim for perfection the first time when you're modifying it, especially with the way carburetors work. And the same thing with these distributors. You got to kind of do things over and over again, see what your engine likes best. Old cars are very tactile. You got to get a really nice feel of how everything works. Sometimes engines will like something, sometimes they won't. It really depends. Video was a bit talkative, a little bit nerdy, a bit technical. Either way, for those of you who like to dive into those kind of things, I hope you enjoyed. I'm gonna go ahead and enjoy the rest of my drive.